The new Dodge Colt models for 1976 offer car buyers all the handling, economy, and styling features of previous models, plus engineering refinements that make these vehicles better than ever before. For the Plymouth side of the family, we now have the brand new Aero models. A quick look at the model lineup shows that the Colt is available in 5 basic models, while Aero is introduced in 3 basic models. Although the Aero is completely new to some technicians, we are only able to cover major components here. Colt models share many of these components, so we'll point out the similarities and differences as our story progresses. The Colt instrument panel is essentially the same as before, with oil pressure and charging signal lamps instead of gauges. The panel is held in place by 3 screws at the top, 2 at the bottom, and 1 inside the glove compartment. The Aero panel is slightly different in layout, and on some models the console has an oil pressure gauge and ammeter instead of signal lamps. This panel is secured by 3 screws at the top, 2 at the left side, and 3 in the ash receiver opening. Now, moving to the front suspension, we find that both Colt and Aero have strut-type upper units, which combine a coil spring with a shock absorber and wheel spindle. At the bottom, the Colt unit has an A-shaped control arm, which pivots up and down and braces the spindle against fore and aft displacement. The lower end of the Aero suspension unit has an I-shaped control arm, held in alignment by a strut which is rubber isolated at its front attachment point. Disc front and drum rear brakes with power boost are standard on all but the 1600cc Canadian models. Except for Canadian models, the brake hydraulic system now includes a combination valve. Both car lines are available with automatic or manual shift transmissions. 3 options can be selected with a 1600cc engine and 2 with a 2000cc engine. All are floor shift type. The rear axle in both cars is a conventional hypoid gear type with a removable carrier assembly in a one-piece axle housing. Axle shaft bearings are press-fitted on the shafts. The same basic cooling system is used in both car lines. The molded nylon fan has 5 or 6 blades, depending on the engine model. Some models have a torque clutch fan drive. An overflow reserve tank is used on all models. The 1600cc engine for both car lines is essentially the 1975 model with minor parts improvements. The secondary air injection system pump has been replaced with a new reed valve exhaust impulse system, which we'll discuss later. A 2000cc engine is also available for both car lines. Based on the previous model, this new engine introduces the exclusive silent shaft feature, an industry first. The general layout of the silent shaft engine is similar to its predecessor, but its unique vibration damping system eliminates engine vibration periods which produce booming noises inside the car. The silent shaft vibration damping system uses 2 counterbalance shafts, 1 on each side of the engine. The shaft on the right side is located slightly above the crankshaft. The other is also above the crankshaft, but somewhat higher. The counterbalance shafts rotate in opposite directions, with the left side shaft turning the same direction as the crankshaft. These shafts turn at twice crankshaft speed to produce forces equal and opposite to those which generate the unwanted vibration. The counterbalance shafts are driven by a single-width roller-linked chain located in front of the camshaft timing chain. The right side shaft is geared to reverse its rotation. The shaft drive gears are enclosed in the oil pump housing, where they also function as oil pump gears. A pressure-operated timing chain tensioner is built into the oil pump housing. The driven gear inside the oil pump is keyed to the front end of the balance shaft and turns the shaft counterclockwise at 2 times crankshaft speed. The counterbalance shaft drive sprockets are identical and can be interchanged. They have a deep chamfer on one side and are installed with the chamfer facing outward on the upper shaft and inward on the lower shaft. The shaft drive chain must be installed with its bright-plated links aligned with mating marks on the sprockets. If either balance shaft is out of time, the counterbalancing forces will increase rather than decrease the vibration. The chain is kept in position by 3 chain guides. The upper guide, which is adjustable, is installed first, followed by the guides at the side and at the bottom. The camshaft timing chain of both engines is also installed with its bright links aligned with the timing marks on the crankshaft and camshaft sprockets. The ignition systems for both engines are basically the same. The 1600cc engine distributor is angle mounted on the timing chain case and has a fine timing adjustment mechanism built into the dual diaphragm assembly. The 2000cc engine distributor is mounted horizontally in a bore in the left side of the cylinder head. Timing is adjusted by turning the distributor body as required. The timing index of both engines is cast into the front of the chain case at the left side. The crankshaft mark is a notch at the rear of the shaft pulley. When checking the ignition timing setting on both engines, the rubber cap on the retard side of the vacuum control chamber must be removed to prevent any vacuum retard action. After setting the timing, be sure to replace the cap and recheck the timing. Except for calibration differences, the carburetors for both engines are essentially the same. A steel ball shutoff valve is added in the float chamber to prevent rollover leakage. The idle mixture screw is located under the fuel shutoff solenoid. On manual transmission models, the inner throttle shaft screw adjusts idle speed. The middle screw is for dashpot adjustment. The outer screw adjusts fast idle speed. For automatic transmission models, the inner screw also adjusts idle speed, and the outer screw adjusts fast idle speed. There is no dashpot screw. To check or adjust idle speed and mixture, the engine must be fully warmed up. Then, with idle set to specified speed, remove the secondary air system hose at the reed valve and cap the valve inlet. Idle carbon monoxide indication must be between 1 to 2.5%. To adjust idle mixture, continue the operation by setting idle speed about 50 RPM lower and then adjust the mixture screw to the leanest possible setting without causing misfiring. After mixture adjustment is completed, remove the cap and reconnect the air hose at the reed valve. Adjust idle speed to the specified setting and snap the throttle a few times to make sure the adjustment is correct. The reed valve is part of the simplified secondary air system which replaces the air pump system. In this system, the pressure drop which occurs between exhaust impulses is used to draw fresh air from the air cleaner. The air flows through the one-way reed valve into the exhaust ports where it reacts with the gases to reduce carbon monoxide and hydrocarbon emissions. The remaining emission control systems are similar to those used on other Chrysler Corporation vehicles. The evaporation control system has a vapor vent line leading to a charcoal canister from a vapor liquid separator at the fuel tank. A second vent line leads to the canister from the carburetor air cleaner. A new rollover check valve is installed in the line between the canister and the fuel tank. This is a one-piece molded valve with two check balls which shut off liquid fuel flow to the canister and air cleaner if the car accidentally rolls over. The Aero evaporation control system tank vent line has a pressure vacuum valve in the left rear body section instead of in the filler cap. The crankcase ventilation system uses two rocker cover hoses to recycle blow-by gases. At part throttle, gases are drawn from the side hose into the intake manifold. Fresh air from the air cleaner enters through the front hose into the engine. At wide open throttle, gases are routed to the combustion chambers through both hoses. A two-section thermal valve in the water jacket controls EGR valve operation and, when needed, advances the ignition timing to prevent possible engine overheating. When the engine is cold, the thermal valve vents the EGR vacuum circuit to keep the EGR valve closed. At this stage, the distributor retard vacuum circuit is not vented, so it operates normally. As the coolant warms above 131 degrees, the valve air vent is cut off from both vacuum circuits, allowing normal EGR valve and distributor retard operation. Above approximately 203 degrees, the thermal valve continues normal EGR valve operation but vents the distributor retard line. The timing now moves to full advance, speeding up the engine and cooling action until coolant temperature drops below the cut-in point. The heated air intake system for both engines draws air in through a simplified version of the air heating system used on other Chrysler Corporation vehicles. Here, the hot air control valve is operated directly by a bimetal coil located in the snorkel. California models are equipped with a thermal reactor in place of the standard exhaust manifold. Exhaust gases are mixed with secondary air inside the reactor and reburned to substantially reduce emissions before they leave the tailpipe. There's more to the Colt and Aero story than these brief highlights, but you're off and running, so be sure to dig into your reference books and service manuals for the additional know-how that will help you contribute to the success of your customer assurance program.